Assalamu alaikum students, hope you are doing good. First of all, mark your attendance in the chat box. I hope you are doing good. And students, kindly turn on your camera, otherwise I have to remove you from the class. Arfa, please open your camera, okay? So class, we will continue the same chapter, unit 11, that is sound. And today you have to give your test in Google Classroom after 12 o'clock, right? So you also have to prepare for this, right? Which I told you in the previous lecture. The contents we will cover in the today lectures are includes sound intensity level, reflection echo of sound, and speed of sound. After covering this lecture, you will be able to know about that what is meant by intensity level and its units. Then you must be know that how can you describe the reflection of sound that produce echo. You will be able to solve problems based on mathematical relation learned in these units, right? The different formulas we will learn in this lecture, and then you will be able to use these formulas to solve different problems, right? Now we will take start from sound intensity level. Alpha, beta, kindly on your camera. Okay. The human ear responds to the intensity ranging from 10 power minus 12 watt per meter square to more than 1 watt per meter square, which is loud enough to be painful. So class, in the previous lecture, we discussed about intensity and intensity of sound, and we have know that the sound for intensity sound unit has watt per meter square, right? So the minimum value or the faint sound that human ear can listen is about 10 power minus 12 watt per meter square, right? And the maximum sound that our ear can bear is about 1 watt per meter square, although it's a very loud sound and it can cause a pain, right? So this is the range of the intensity of the human ear that can be vary from 10 power minus 12 to 1 watt per meter square. Because the range is so wide, intensities are scaled by the factors of 10. So you can see that this is 10 power minus 12, then after this 10 power minus 11 minus 10. So these values, they are very wide. So what we do, we just scale them by the factor of 10, like in power of 10, right? So the, as I told you, that the very faint intensity of sound that you can hear or we all can hear is about 10 power minus 12 watt per meter square. This is the smallest sound or lowest sound that we can hear, right? And it is known as, and we take this faint sound as a reference intensity, and that is known as a zero bell. And this zero bell is given name after the scientist Alexander Graham Bell, right? So whenever somebody asks you that can you define what is zero bell, so you can say that it is 10, it is a faintest sound that is 10 power minus 12 watt per meter square, and we also call it a reference intensity that is known as zero bell, right? So the loudness of a sound is directly proportional to the logarithm of intensity, if I speak loud, there will be a more intensity, right? If my voice is low, the intensity will be low. So loudness and intensity, they have the direct relation with each other, right? So when we take the relation between loudness and intensity, we will take in the form of logarithm. Here it is, loudness is directly proportional to the log of intensity. This L is the loudness, and this log is the logarithm sign, a symbol, and I is the intensity. If the intensity is more, loudness will be more. If the loudness is less, the intensity will be less, right? So if we want to remove this proportionality constant, what we have to do, we have to place some constant, right? So by using the by placing the constant, we can able to put a equal sign. To remove this proportionality sign, we use the constant k, that is known as the constant of proportionality. So we can write L is equals to k log I. So L is again the loudness, k is a constant of proportionality, and log I is the logarithm of intensity. And we give this equation name as 11.1, right? Where k is a constant of proportionality. Now this is the relation between loudness and logarithm of intensity. And this loudness sound is unknown. We don't know what is the loudness, because everybody has a different intensity, right? So what we do, correspond to this equation, we will derive another equation by relating this equation. If we say the loudness of a faintest audible sound intensity taken as L naught, this is the very small sound, right? That is represented by L naught. So L naught be the loudness of faintest audible sound of intensity I naught, and its intensity must be I naught, because the sound is faint, so its intensity will be also low, so it's represented by I naught. And L be the loudness of an unknown sound of intensity I, that I told you before, right? So if this is L naught, I naught, if we see the equation 11.1, it will be like L will become L naught, K same remains same, logarithm is same, and I intensity will be I naught. Arfa and Krotlan, kindly turn on your camera, because it is not allowed to turn off the camera, right? So for whole lecture, you have to keep your camera on. So by using equation 11.1, we can make a equation 11.2, that is L naught K log I naught, right? So what we have to do, we are going to find out the sound intensity level, and sound intensity level is basically the difference between faintest sound to the unknown sound intensity, right? So that's why we are developing these equations. So girls, it is clear to you. If there's any confusion in this lecture, you can ask me now. Okay. So now what we have to do, we have to subtract equation 11.2 from 11.1. Then we will get L minus L naught. L minus L naught is equals to K log I minus I naught. You simply have to subtract the previous two equations. So in the chapter of logarithm, you have learned that if there is a difference between two log values, you can divide them, right? So you can write this equation as L minus L naught remain as it is equals to K log I minus log I naught can be written as log I divided by I naught, because the difference between two log values can be divided, right? It is the law of logarithm you have learned in mathematics. This difference L minus L naught between the loudness L of an unknown sound and the loudness L naught is called the intensity level of unknown sound. So that intensity level of unknown sound we are going to find out. So our main aim is that in this topic we have to find out the relation for intensity level of unknown sound that we have find out that we have find over here. So we can say that intensity level is equals to K log I by I naught. So this is the relation. The value of K depends not only on the unit I and I naught, but also on the unit of intensity level. So this value depends upon the value of units of intensity level, right? If intensity I of any unknown sound is 10 times greater than intensity I naught of the faintest audible sound, let's say if you have this intensity I, and this intensity I is 10 times more than this faint sound, then we can write as I is equals to 10 times I naught. and the intensity level of such a sound is taken in a unit is called bell. If you remember in the previous slide, we have discussed that the faintest sound is taken as a 0 bell, but this such sound is taken as a unit as a bell, right? The value of k becomes 1. Therefore, using k is equals to 1, the equation 11.3 becomes. So if we take the value k is equals to 1, this equation will be intensity level log I by I naught bell. So if you see that the bell is a very large unit of intensity level of sound. Generally, a smaller unit called decibel is used. So as the bell is a very large unit, so mostly we deal in case of sound intensity level, we use the unit decibel, right? And decibel is abbreviated as dB. For deci, we simple as D, and bell is for capital B. So this is the unit of intensity level of unknown sound. It must be remembered that one bell is equal to 10 decibel. One bell is equal to 10 decibel because deci has the value 10 power. If you remember the prefix, the value of deci is 10 power minus 1. So this 10 power, this is a positive one, and this is a 10 minus 1. They will be cancelled out, and they will be again give you a bell. So one bell is equals to 10 decibel. If the intensity level is measured in decibel, the equation 11.4 becomes intensity level is equals to 10 log I by I naught decibel. So what we do, we just place decibel instead of bell. So this is equation 11.5. We can construct a scale for measuring the intensity level of sound. Such scale is known as a decibel scale. The intensity level of different sound is decibel in given in table 11.1. So girls, this is a relation that we have derived for intensity level, that is 10 log I by I naught. So whenever the problem comes to you that you have to find out the intensity level of any sound that is given to you, you can just use this formula, put the value in this formula, and find out the required unknown, right? So now we see the table. If you see the table 11.1, and that is also given in your book on page number 25. Sources of sound intensity. In the previous lecture, we have discussed that the intensity has a unit watt per meter square. And in today's lecture, we have discussed about intensity level. And we know that the intensity level is measured in decibel, right? So the first source of sound is nearby jet airplane. You all are familiar with the sound of nearby jet airplane. So the intensity of this airplane is about 10 power 3, and in decibel, its intensity level is 150 dB. Now, if you are know that jackhammer, what is a jackhammer? Jackhammer is basically a machine that is used to break the hard object. For example, if we want to break a tile or a brick, we can use a jackhammer. So jackhammer and fast train, they have the same intensity, that is 10 power 1 watt per meter square, and both have intensity level that is 130 decibel. Then siren, or all you are familiar with the siren, it's an alarm sound. So its intensity is 10 power 0, and intensity level is 120 dB. Then lawn mower is basically a machine that is used to uh, cut the grass or small plants from your lawn to maintain your lawn, right? So this lawn mover has an intensity sound of about 10 power minus 2, and intensity level is 100 dB. Then vacuum cleaner, all you are familiar with the sound of vacuum cleaner. So its intensity is 10 power minus 5 watt per meter square, and its intensity level is 70 decibel. Then mosquito buzzing, its intensity is 10 power minus 8, and its intensity level is 40 dB. Then the sound of whisper that we usually do with our friends, right? When we want to talk some secret, right? So its intensity is about 10 power minus 9, and intensity level is 30 dB. Then rustling of leaf, if you just walk on a rotten leaf, you just hear the source of a rustling leaf, that is 10 power minus 11 watt per meter square, and intensity level is only 10 dB. Then the faintest audible sound that I told you in the start, or threshold sound. For example, threshold is basically if you just slide the door on the base, it's known as a threshold, and it is made of wood or a plastic, right? So the most faintest audible sound has intensity is 10 power minus 12, and its intensity level is 0 dB. So when we were discussing the topic of intensity level, we have discussed the human ear also bear the faintest audible sound, that is 10 power minus 12. And we take this sound as a reference points, right? So these are the sources, these are the sources of sounds, and we have from this table we have know that what are the intensities and intensity levels of these sources of sound. So girls, do you have any problem till here? If you have, you can ask me now. Now we will see the example relate to this sound intensity level. Calculate the intensity levels of a faintest audible sound and rustlings of leaves. So you have to find out the intensity levels of two sounds. One is faintest audible sound, that is a very minimum sound, and that we have discussed. It's about 10 power minus 12 watt per meter square. And rustling of leaf is also discussed. That is we discussed in the previous table. If you see the page number 25, its value is 10 power minus 11, and its intensity level is 10. So you have to find out their intensity level. So what you have to do, you have to use the formula that we have discussed before, that is intensity level is equals to 10 log I by I naught dB, right? You have to use this formula to find out the intensity level of these sounds. First of all, we have to find out the intensity level of faint sound. So first of all, we have to write the formula, that is intensity level is equals to 10 log I by I naught. Okay, this is the formula we have to use in both cases. First of all, we have to find out the faintest audible sound. For faintest audible sound, we know that we have to find out the intensity level. So 10 will remain as it is, log will be as it is. For I, we have to place 10 power minus 12 by using the table that is given in your book on page number 25, and it is the last value that is mentioned in the table, that is faintest audible sound threshold, that is 10 power minus 12, and the reference we always take is 10 power minus 12. So when when we put the values over here, so 10 power minus 12 and 10 powers minus 12, they will be cancelled out with each other. So we will get the log 1. So log 1 is equals to 0. So if we multiply 0 with 10, we will get 0 decibel, right? So in this way, we can find out the intensity level of faintest audible sound. So the intensity level of faintest sound is equal to 0 decibel. Then the intensity of a rustle of leaf is equals to I is equals to 10 power minus 11 watt per meter square. This value is written in the table in book, right? And this value will be given to you because you don't have to memorize these values, right? So again, you have to put this value in the table. Intensity level due to the rustling of leaf, which is equals to 10 log 10 power minus 11 divided by 10 power minus 12 dB. in I2 you always have to put 10 power minus 12 because it is the faintest sound, and we have to take this as a reference point. So 10 power minus 12 is always put in I naught, right? So if you simplify it, minus 11 minus 12, then when minus 12 is come it will be come in numerator, it will be plus 12. So minus 11 plus 12 is equals to uh, plus 1. So 10 log 10 dB. Log 10 is equals to 1. So if 1 is multiplied by 10, it is equals to 10 dB, right? So in this way we can find out the intensity level of rustling of leaf, that is 10 dB. If you see your table on page number 25 in table 11.11, you can know that these intensity levels are given, and that and we also have calculated, and these are the correct values. Now, for your information, a sound wave with a frequency of 3500 hertz. So, what is frequency? Frequency is number of vibrations in 1 second. That is known as a how many waves that can pass in a 1 second are known as a frequency. So, if you have a frequency of 3500 hertz and its intensity is 80 dB, and if you take the other sound that is 125 hertz and its intensity is 80 dB, so you will be feel this sound as a very loud sound, right? It is because our ears are more sensitive to 3500 hertz sound than to 125 hertz sound, because a 3500 hertz frequency sound is very high, and 125 hertz sound is less as compared to 3500 hertz. Therefore, intensity by itself does not mean loudness. Loudness is how our ears detect and our brains perceive the intensity of sounds wave. So loudness is basically depends upon on our ear as well, right? So if you see for information, if you see the table on the right side, logarithm scale and the linear scale. First of all, you must know what is a logarithm scale and what is a linear scale. Logarithm scale is basically a scale in which you have to compact a very wide values. If you have a very large values and you want to use these values, so you cannot write a very large numbers all the time, because if you write all large numbers all the time, what will we do? You can make any mistakes. So that's why we make these large values, and we write these large values in a compact form, right? And that we called a logarithm scale, right? That is decibel, because decibel bell is itself a very large unit, so we use it as a decibel, right? The linear scale, in linear scale all the values are divided into equal parts. And linear scale, if we take linear scales as amplitude, and in previous lecture we discussed about amplitude. Amplitude is basically a height, and that height is measured in meters. For decibel, the unit is dc. For logarithm scale, we use decibel, and that is dB. And for linear scale, we use amplitude, that has the unit meter. So for if there's a 0 decibel, the amplitude will be 1 meter. If there's a 20 decibel, the amplitude will be 10 meter. And if we have 40 decibel, then the amplitude will be 1000 for 60, 1000 for 80, 10,000 for 100, 1 lakh for 120, 1 lakh meter. So these are the logarithm scale, and they can be written as a linear scale. The decibel scale is a logarithm measure of the amplitude of sound wave, and these amplitude are basically of the sound wave. You can see that let's say this is a sound wave. So girls, where I have put the mark, this is the height. This height is known as amplitude, and this is the height on the negative axis as well, and it is also known as the amplitude. So these are the amplitude of the wave. Equal intervals correspond to the multiplying by 10 instead of adding equal amount. So this is just for your information. Now, the other information that is given in your book is thin walled glass globules can vibrate when hit by a sound wave. This is due to the phenomenon of sound known as resonance. Some singers can produce a sound note of particular frequency such that it vibrates the glass so much that it shatters. So sometimes you hear when you just close the your door very strongly, what will happen? Your glass will be start vibrating, right? And because they hit the sound waves, and that's why they produce a sound. Or sometime if you see if there's a lot of storm outside, again you see that your windows, they are just shaking, they are producing a sound. So this is this is just given in this information. Then some people use silent whistle to call dogs whose frequency lies between 20,000 hertz to 25,000 hertz. So as dogs, they can hear the frequency of 20,000 hertz to 25,000 hertz. So if we just whistle, dog can listen that our sound. It is silent for human but not for dogs, because the audible frequency ratings for dog is much higher, right? So if we just whistle, the dog can hear us. So mostly people, they use the whistle sound to call the dogs, because this silent sound is silent for human beings but not for the dog. They can hear this small or lower sound, right? So girls, do you have any confusion till here? Yes, girls. If you have any confusion, you can ask me now. And yes, girls. Yes, Krutulan, Sarah, do you have any confusion regarding this lecture?
No, ma'am. No, ma'am.
Okay, now I'm ending the meeting. If you have don't have any confusion, and I will start the next class on 9:40, right? Okay, thank you. Allah Hafiz.